The effect of visible light and gibberellic acid hormone on seed viability and vigor in mung bean or Vigna radiata. Problem formulation. Does the color of visible light and gibberellic acid hormone affect the seed viability and vigor in mung bean? How is the effect of the color of visible light and gibberellic acid hormone toward the seed viability and vigor in mung bean? Objectives. To know the color of visible light and gibberellic acid hormone affects the seed viability and vigor in mung bean. To know how is the effect of the color of visible light and gibberellic acid hormone toward the seed viability and vigor in mung bean. Hypothesis. Certain colors of visible light affect the seed viability and vigor in mung bean. Gibberellic acid has a boosting effect toward seed viability and vigor in mung bean. In tools, we need containers, measuring cylinder, funnel, cup and steering rod, and light circuit set. In materials, we need mung beans, cotton, gibberellic acid, and water. Methods. First of all, make a seedling medium. This seedling medium is made using cotton placed in a container. In this experiment, we need 10 seedling medium. Next, sow mung bean seeds on the media. Each container has 25 mung bean seeds. Then, seeding is carried out up to 10 containers. Then, dilute the pure gibberellin liquid. This pure gibberellin liquid has 1000 ppm. To make 50 ppm, here I use 5 milliliters, which is dissolved in 100 milliliters of water, and then stir it until dissolved. In the hormone treatment, 5 seedling media were each given 50 ppm gibberellin liquid as much as 75 milliliters. In treatment without hormones, 5 seedling media were each given 75 milliliters of water. Next, The seedling media was put into the light circuit set room, where each color room included one media with hormone treatment and one without hormone treatment. After that, we turned on this light circuit set. These observations were made for 4 days, and this experiment was carried out 2 times. Experimental results and discussion. Seedlings or sprouts are differentiated based on their normal and abnormal. Normal sprouts have good development and growth, which have healthy cotyledons, the presence of primary and secondary roots, and other characteristics of normal sprouts. While abnormal sprouts have characteristics such as defects or damage to sprout organs such as cotyledons and roots, weak and unstable development, and other abnormal sprout characteristics. The further data collection is carried out on normal sprouts. The results of this experiment used 2 formulas: germination percentage to measure sprout viability and figure index to measure sprout figure. According to Makassar et al. 2021, viability is the vitality of seeds that can show the process of seed growth. The viability parameter used here is germination percentage. Figure index is an indicator to determine the uniformity of germination, according to Makassar et al. 2021. These 2 parameters are presented in the following formula. Germination percentage equals total of normal seedling after 4 days after planting divided by total of planted seeds times 100%. Figure index equals total of normal seedlings in first observation, which means 2 days after planting divided by total of planted seeds times 100%. All sprouts were counted and the following viability table for germination percentage was obtained. The data were tested with a randomized group designed factorial ANOVA or analysis of variance with the result of real sources of diversity. Then, further tests using DMRT or Duncan's multiple range test and obtained the following data. The number in each column and row followed by the same letter are not significantly different according to DMRT at the 5% level. The application of gibberellin hormone significantly increased germination percentage. Besides that, the color treatment also significantly increased germination percentage in the order of red-blue, white-yellow, and green. The graph also shows the difference in the mean germination percentage with the addition of gibberellin hormone treatment, as well as in the treatment of different colors of visible light. For the figure test, all sprouts were counted and the following figure table for the figure index was obtained. The data were tested with a randomized group designed factorial ANOVA or analysis of variance with the results of real source of diversity. Then, further tests using DMRT or Duncan's multiple range test and obtained the following data. The number in each column and row followed by the same letter are not significantly different according to DMRT at the 5% level. The application of gibberellin hormone significantly increased the figure index in each treatment except red, but still had differences in figure index. Besides, the color treatment also significantly increased the figure index in the order of red, blue, white, yellow, and green. The graph also shows the differences in the average figure index with the addition of gibberellin hormone treatment as well as in the treatment of different colors of visible light. Gibberellin hormone works by entering the aleuron layer and stimulating the activation of the amylase enzyme. This enzyme then enters the endosperm and converts starch into sugar and energy. In addition, gibberellin also causes the seed coat to be more permeable to water and air. The treatment of the different light colors gives an influence on germination. Giving red light can accelerate photosynthesis in sprouts and followed by blue, white, and yellow where this can be compared from the table and graph of viability and figure. While the provision of green light shows slower germination results. This is because most of the green light is reflected back by photosynthetic pigments and only a little is absorbed by the sprouts. Conclusions. Based on the data presented, it can be concluded that the application of gibberellin hormone and also the color of visible light treatment can have an effect on the viability and figure of mung bean sprouts. Gibberellin hormone 50 ppm in mung bean seeds can accelerate the germination process. Gibberellin enters the aleuron layer and stimulates the activity of amylase enzyme. This enzyme then enters the endosperm and converts starch into sugar and energy. In addition, gibberellin also makes the seed coat more permeable to water and air. Different light color treatment on mung bean seeds also affect germination. Giving red light can accelerate photosynthesis in sprouts and is followed by blue, white, and yellow. Meanwhile, green light shows slower germination results. This is because most of the green light is reflected back by photosynthetic pigments, and only a little is absorbed by the sprouts.